Alright guys, today we're going to finish up lesson 3.2. This is part B. And really, really what we're going to look at here are our three main trig functions for some acute angle theta, which is sine, cosine, and tangent. And so we're really going to look at it through the form of a right triangle. And so if you look over here, we got our angle theta right here. And then remember what your trig ratios are, that phrase that you learned in geometry, that SOHCAHTOA phrase, where sine is the opposite leg over the hypotenuse, cosine is the adjacent leg over the hypotenuse, and then the tangent is formed by taking the opposite leg over the adjacent leg. Okay, and so we use that. And so that really comes into play here when we're talking about we've got a radius which turns into our hypotenuse. And then you see we have to form that vertical leg, that red dotted line over there. We form that vertical leg to create a right triangle, and that's what allows us to use these trig functions here. Okay, and so the right triangle is there. So if we look down here, we talk about this first one right here. It says let x and y be a point R, or R is the radius units from the origin, on the terminal side of the rotating ray. If theta is the angle in standard position, remember along the x-axis, to the ray, then the following ratios will hold. Okay, and so what we've got here, if we have in our case a radius of 1, if I draw my right triangle here, bring down that leg, got a right angle, this is the x distance, this is the y distance. Okay, so if we're looking at the right triangle form, we need to be able to convert those into coordinate form. And so sine of theta we know is the opposite leg over the hypotenuse. If we're talking about coordinate form though, it's our vertical leg over our radius, which translate to basically the distance of y over r. So when we're doing sine of theta, we can just say y over r. Same thing with cosine. Cosine was the adjacent leg, and that coordinates to the horizontal leg over the radius, because remember the radius acts as a hypotenuse in our right triangle, which means x over r. And then finally, we said tangent was opposite over adjacent, which in coordinate form translates to vertical leg over horizontal leg, which would be simply y over x. Okay, so we got these three main properties that'll hold here, that sine is y over r, cosine is x over r, and tangent is y over x. Alright, so now we're going to start developing the unit circle here. And we're going to go about it using some right triangles and some special right triangles that you learned back in geometry. But eventually we'll get the whole unit circle completed here. And so if you remember, there were two special right triangles that we learned in geometry, the 30, 60, 90 and the 45, 45, 90. And this really comes into play when you're trying to learn the unit circle. And yes, you do have to learn it. You have to memorize it and understand it. But if you remember, all right, the short leg, which was across the 30-degree mark in a 30, 60, 90, we just always gave it the value of x. So that one kind of stayed across from the 30-degree angle. And then the longer leg, we always multiplied it, the short leg, by root 3. And that was always across from the 60-degree angle. And then obviously the hypotenuse is across from the 90-degree angle. And we always took the short leg and multiplied it by 2. And that would give us the length of that leg here, the hypotenuse. So going back to thinking about that 30, 60, 90 triangle, you had the short leg was across from 30 degrees, and we always gave it the value of x. The long leg was across from 60, and that always gave you multiply the short leg by root 3 to find its length. And then finally, to find the hypotenuse, we always took the short leg and multiplied it by 2. So now, if I'm trying to figure out on this triangle what these legs are equal to, if the radius is 1, going into relation of, let's say, the 30 degree, because that's the one we know. If we know 30 degrees, then when we start talking about opposite leg over hypotenuse, well, for 30 degrees, that would be x over 2x, the hypotenuse. Well, the x's simplify, and you get 1/2. So if the radius is 1, okay, if the radius is 1, in this case the hypotenuse, then the short leg would be half, okay? And then right here, if we have that, to find the long leg, we would simply say, okay, well, let's take x root 3, and let's divide it by the hypotenuse, because we're finding the cosine of 30 now. The x's cancel, and we get root 3 over 2 is that distance when the radius is 1. And I keep repeating that the radius is 1 because that's what the radius is in our unit circle. And so what we're doing is we are developing some common links that we're going to have for x and y here in just a minute. But we also need to look at the 45, 45, 90 triangle, which was a special right triangle you learned. And remember, so that means you have two angles that are 45 and one that's 90. The two legs are the same. It's an isosceles triangle. So both angles across, or both sides across from 45 degrees, we gave the value of x. And then we always said that, well, you can take x and multiply it by root 2 to get the hypotenuse, which is across from the 90 degree angle. Okay? And so if we again make that radius 1 right here, well, 45, 45, 90, going across either one of them, if we say x over x times root 2, well, the x's cancel. Okay, and you get 1 over root 2, but when you simplify that denominator, you get root 2 over 2 as your answer. And those are going to be some important links for us to look at here in just a minute as well. Okay, so let's look at example 6 here. So we want to find the values for sine, cosine, and tangent of the angle theta, which is equal to 30 degrees, given the coordinates on the unit circle. Okay, so here's the key. For this right here, you notice the radius is 1. Okay, and so really what happens is, if we're trying to figure these out, sine of theta, remember we said was y over r. Well, if the radius is 1, we're just going to take the y coordinate, which is 1/2, and divide it by 1, which is just 1/2. So the sine of 30 degrees is 1/2. It's the y coordinate. The cosine, we said, of theta was x over r. Well, r is still 1. And the cosine is just the x coordinate, which is root 3 over 2, divided by 1, which is just root 3 over 2. And then remember that tangent is going to be y over x. So y is 1/2. X is root 3 over 2. Remember, when you divide fractions, you keep, change, flip, multiply by the reciprocal. So we're going to multiply by 2 over root 3. The 2's cancel, and we get 1 over root 3. But we got to rationalize that denominator. And so really, the tangent is root 3 over 3. So again, when the on the unit circle, when the radius is 1, you can just get by with saying the sine is the y coordinate, the cosine is the x coordinate, and then tangent is simply y over x. Okay, so let's look at now, that was for 30 degrees, and you'll see how these build up in just a minute. Let's look at 45. Well, 45 from the 45, 45, 90 triangle, okay, was root 2 over 2, root 2 over 2. Again, the radius is 1, so we really don't even have to divide by anything. Remember, the sine of theta is the y coordinate, that's root 2 over 2. The cosine is the x coordinate, root 2 over 2. And remember, tangent of theta is going to be y over x, which is root 2 over 2 divided by root 2 over 2. Well, you divide anything by itself, and you get 1. So the tangent of 45 is 1. So we've done 30. We've done 45. Now we need to do 60 here. I want to find the values of sine, cosine, and tangent for 60 degrees. So you see, the relationship is that it takes the 30 degrees and it just flips them. Radius is still 1. So what we can say is the sine of theta is now root 3 over 2. Cosine of theta is the x-coordinate, which is 1/2. Now tangent is y over x. So that's root 3 over 2. And that's divided by 1/2. And that's just going to give us root 3. So we've done 30, we've done 45, we've done 60. We want to find the values of sine, cosine, and tangent for 90 degrees. And then from there,
enjoy your nice winter break.
And then from there we'll figure out sine, cosine, and tangent. Well, if you think about 90 degrees, we go back to being in standard position. Remember, it starts here, and if it rotates 90 degrees, well, we just end up right here. So that forms a right angle there at 90 degrees. Well, on the unit circle, that's the point 0, 1. That's the point 0, 1 right there. So, same rules apply here. The sine of 90 degrees is the y-coordinate, which is 1. The cosine of 90 degrees is the x-coordinate, which is 0. And then finally, when you do tangent of 90, which is y over x, that's 1 over 0. Remember, when 0 is in the denominator, that's undefined. Okay, can't have 0 in the denominator. So we went through and we've defined sine, cosine, and tangent for 30, 45, 60, and 90 degrees. And what we've come up with is that the sine of theta is equal to the y-coordinate. The cosine of theta is equal to the x-coordinate. And the tangent is really equal to y over x, which in turn is the slope of the terminal ray. Slope of the terminal ray. So now, continuing on looking at this, alright, we're just going to keep summarizing, and eventually what we'll do is we will draw our unit circle. So now, if you look right here, it says summarize the exact values of 30, 45, and 60 degrees. Make sure we rationalize. So this is just taking everything we've talked about, put it in a nice clean table for you. So at 30 degrees, we said the sine of 30 was the y-coordinate, which was 1/2. The cosine of 30 was root 3 over 2. And the tangent of 30 was root 3 over 3. And point out the fact, got to make sure we understand that pi over 6 is 30 degrees. They're equivalent. For 45, we figured out that sine was root 2 over 2. Figured out cosine was the same thing. And when you divide those two, you get tangent of 1. And then for 60 degrees, we ended up flipping them. So the cosine of theta was root 3 over 2. The cosine of theta of 60 degrees was 1/2. And then finally the tangent, when you divide root 3 over 2 divided by 1/2, we figured out was root 3. Okay, so now let's look at our quadrantal angles. Okay, and all that is an angle whose terminal side lies along one of the coordinates. So really all that is 90 degrees, 180 degrees, 270. Those are your quadrantal angles because their terminal side lies on one of the axes of the coordinate. So what happens is this is 90 degrees, this is 180 degrees, this is 270 degrees. So if you look at the coordinates here, the sine of 0, remember that's going to be the y-coordinate. That's going to be 0. Okay. The cosine of 0, if you look at the coordinates, is going to be 1. And remember, the tangent is sine over cosine, so that's 0 as well. When you look at 90 degrees, the sine of that is 1. The cosine would be 0. But remember now, if you do 1 divided by 0, you get undefined. Looking at 180, negative 1, 0. Well, the sine of that is 0. The cosine is now negative 1. And when you do 0 divided by negative 1, you get 0. And finally, down here at 270, the sine of that is negative 1. The cosine, the x-coordinate, is 0. And when we do negative 1 divided by 0, we get undefined. Okay? So that's just kind of summarizing everything into some nice clean charts for you. And so what we're going to do now is we're going to take all that, we're going to develop our unit circle. And so here's the unit circle, 16 points. Yes, you do have to memorize it, okay? And just to remind you that this is quadrant 1. This would be quadrant 2. This is quadrant 3. And this is quadrant 4. Okay, and so remember that both x and y are positive here. X is negative here, but y is positive. Both are negative in this quadrant. And then x is positive here, y is negative. So that'll come into play when we start doing our points. Now, to clarify something, this is all in radian measure, okay? But right here, remember, pi over 6 is the same as 30 degrees. And then it goes to 45 degrees, pi over 4. And then it goes to 60 degrees, pi over 3. And then this is 90 degrees. So the pattern is plus 30, plus 15, plus 15, plus 30. So then you repeat that pattern. This becomes 120 degrees, plus 15 is 135, plus 15 is 150, and then plus 30 is 180. And then you repeat that pattern again. That's 210, plus 15 is 225. Alright, and then plus 15 is 240. And then finally this is 270, plus 30. Plus 30 again is 300. Plus 15 is 315, plus 15 is 330, plus 30 is 360 degrees, and we made our way back to 0. Okay, so there's the corresponding degree measures. The angles, the coordinates, okay, are going to follow a pattern as well. So we've already said that this is 1, 0 here. And then we've already defined that this right here has a coordinate of root 3 over 2, 1/2. Pi over 4 had coordinates of root 2 over 2, root 2 over 2. And then finally, remember, they just 60 and 30 just swap, so this is 1/2 and this is root 3 over 2. And then we get to 90 degrees and we have points of 0 and 1, just like that. Okay, now what I said, there's a pattern. We've already talked about the signs of x and y. A sign here in quadrant 2 is x is negative, y is positive. What's going to happen is it's going to basically essentially mirror this quadrant 1. So what happens is now we go in reverse order. This now becomes negative 1/2 root 3 over 2. Then I keep going, negative root 2 over 2, root 2 over 2. And then this becomes negative root 3 over 2 and 1/2. Okay? So if you look, they kind of mirror each other, except they just have to change some signs. So like if you look, I'm highlighting, they mirror exactly opposite the one that they're across from. It's just the signs have changed a little bit. And then that pattern continues down here. I finish, this is negative 1 and 0. Now, same thing. What's going to happen is, if you look at it, I'm going to mirror again what I have and start with the negative root 3 over 2. and then negative 1/2 because both coordinates are negative here. Then it goes negative root 2 over 2, negative root 2 over 2, and then finally swap them up. I get negative 1/2, negative root 3 over 2. And then down here is 0, negative 1. And then finally I'm going to repeat the pattern again. I finished up with negative 1/2 and negative root 3 over 2. So x is positive here, so now it's going to be 1/2 root 3 over 2, negative root 3 over 2, excuse me. And then this one's going to be root 2 over 2, negative root 2 over 2. And then finally, my last one's going to mirror everything. That's going to be root 3 over 2, negative 1/2. And so there's your completed unit circle right there. And yes, that is something that you have to memorize and be able to construct on your own. And so I kind of showed you what I like to do, but if you got a different way that works for you, then that's fine, go for it. Last thing we're going to talk about here is where trig functions are positive and which quadrants. Remember sine, and the inverse of that is cosecant. Sine is the y coordinate. Okay, it's the y coordinate. So where's the y coordinate positive? Well, that's in quadrant 1 and quadrant 2. And then in 3 and 4 it's negative. Cosine is the x coordinate. Where's the x coordinate positive? Well, that's in quadrant 1 and quadrant 4. The other two are negative, 2 and 3. And then finally, tangent is y over x. So the only time it's positive is if y and x are both positive or y and x are both negative, which happens in quadrant 1 and quadrant 3. The other two times tangent is negative. So again, remember, this is y, this is x. Tangent is x over y.